right, partial fractions. So we get the amazing opportunity to work with some rational expressions today. So a defining characteristic of partial fractions, and I know I'm going to be using those, is anytime you have a rational expression. Now, fraction, right? That's what we're talking about. Rational expression is a fraction. So prior to even just jumping right into partial fractions, let's talk about this for a second. If your degree is the same or the numerator is greater, then divide, right? So this is kicking it back to that 8.1 situation again. If your degree is the same or the numerator is greater, then you divide. And there is no partial fractions with that. You just do your division. If not, then any other pattern, you use partial fractions. All right, but here's the key to partial fractions. So yes, you're going to use partial fractions for this. Partial fractions is just a algebraic representation. It's just a way to rewrite rational expressions so that you can actually integrate, okay? You need to be able to factor. But you need to be able to factor the denominator. Or only have a quadratic. All right, which we'll talk about irreducible quadratics by the end of this section. So those are my criteria. All right, so you have to hit these criteria. If it's the same degree or bigger on the top, just divide that. And then you work with it. All right? Okay, so partial fractions. Partial fraction decomposition with simple linear factors. This is that factoring part. So if I just have simple linear factors, this is how I do it. This is an algebraic deal, but it's not one, it's in college algebra textbooks, but it's not one we typically do. So that's why we're talking about it now. So we're going to suppose that f of x is equal to p of x over q of x, right? So I just have this rational expression where I have a function divided by a function, all right? So step one. Factor the denominator into simple linear factors. Factor the denominator into simple linear factors. Okay, that's step one. Step two. So factor the denominator, right? Step two is do the partial fraction decomposition. So that partial fraction decomposition, and we'll look at that and get that set up. That's just breaking down those fractions. All right, just breaking those up, splitting up those fractions. Step three is clear the denominators. So when you break these up, so you're going to factor, then your partial fraction decomposition means I'm breaking up this fraction. Then we're going to clear the denominators. And lastly, step four is going to be solve for the coefficients. And typically, we're going to be using systems of equations. Typically, you will use a system of equations. Oops, try again. All right. So you're going to factor the denominator. So figure out what you're working with there, that q of x, that denominator. Once we figure out what we're working with here, then we're going to break that up. And then once we break that up, we're going to clear out the denominator so that we don't have to mess with those anymore. Then we're going to solve for these coefficients. And you know we're going to do plenty of examples. So let's dive in here a little bit.